Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BBDA, ITM, Lucknow. Today we will take up course KCE 076 Urban Transportation Planning, in which today we will take up lecture 17 Travel Demand Forecasting. References that I have taken: Chakravarti Partha and Das Animes, Principle of Transportation Engineering, Pepe Costa and Previdendus, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering. Some material have been taken from NAPTEL and some material have been taken from internet. The contents today we will take up: travel demand forecasting, transportation demand, land use, trip purpose, travel decisions, sequential demands analysis. So, first of all we will take up travel demand forecasting. Travel demand forecasting is the process used to predict travel behavior and resulting demand for a specific future time frame based on assumption dealing with land use, the number and the character of trip maker and the nature of transportation system. Travel demand forecasting utilizes a travel forecasting model and attempt to answer questions such as how many trips will be made in future, which transportation system will become congested in future, how much ridership will a new transportation service attract. Transportation planning process relies on travel demand forecasting, which involves predicting the impact that the various policies and programs will have on travel in the urban areas. The demand for transportation created by the separation of urban activities. Supply of transportation represented by service characteristic of transportation and network. The forecast process provide detailed information such as a traffic volume, bus patronage and turning moment to be used by the engineers and planning of their designs. Travel demand forecasting, we will take up different steps. In step 1, trip generation, forecast the number of trip that will be made. In a step 2, trip distribution, determine whether the trip will go. A step 3, mode choice, predict how the trip will be divided among the available mode of travel. A step 4, traffic assignment, predict the route that the trip will take, resulting in traffic forecast for the highway system and ridership forecast for the transit system. Transportation demand is the demand for trip that exist in any area. All of the demands may or may not materialize into the physical trip, and some of it generally remains latent and is referred to referred as hidden demand. Transportation demand is a derived demand. It is very important because trips is usually not made for the itself, means no one can wander on the roads, but we have to go for school, then a trip will come in existence. When we will go for the market, then the trip will come in existence. So, in this way transportation demand is a derived demand. A person demand to be imported a person demand to be transported not because they just want to move, but because they want to achieve some other purpose such as reaching a school, offices, etc. The need for achieving some goal creates the need to travel. Travel demand is primarily generated by the population need to work, entertain, socialize, study, etc. Two of the major aspects in travel demand analysis are land use, trip purpose. The land use refers to the pattern of land use in the urban areas. Land use affect the transportation demand through generation and distribution of a trip. The effect of land use in transportation demand is not necessarily a one way effect, but rather a part of cycle in which land use changes transportation needs, which in turn changes land use. We can see in this diagram, we see this is the land use, and after this land use, then there will be change in the trip generation. Then this will improve the changes in the traffic volume, and after that change in transportation facility. Again this will go for the land use changes, means land use changes will make the things every time in a cycle. Trip purpose refer to the purpose for which the trip is being undertaken. Travel demand behavior changes with the trip purpose. For example, a person hardly exercise any choice of work trips, that is, does not necessarily decide every time whether to go to work or not. A person obviously does not decide where to go to work, even the choice of route and mode are not daily decision. On other hand, for recreational trip, an individual makes a large number of decisions such as whether to go or not, first, where to go and how to go. These questions are asked every time, every person. Consequently, the travel demand behavior for work trips varies considerably from that of recreational trip. The example can obviously be extended to other types of trips such as shopping trips, etc. Given the effect of trip purpose on a travel demand behavior, The analysis of travel demand is done separately for different trip purpose. Although the above discussion throw light on some of the factors which affect travel demand, some more understanding of travel demand is necessary before we can analyze the demand and can with some degree of confidence predict the volume on various link of network. Generally, a trip which is the basic quantity in travel demand materializes after trip makers make a certain decision. These decisions can be broadly classified as follow: the decision to travel. The trip maker, given his and her requirement, make a conscious decision to travel so that the requirement can be met. The decision on the choice of destination. The trip maker can also make a decision as to where she or he want to go. For certain kind of trip purpose such as work trip, this decision may not exist yet to another kinds of trips. Such as a shopping trip, there may be certain alternative location to choose from. Decision on the choice of mode. The trip maker can take a decision as to what mode of transportation to use for a given trip. This decision, however, is only available to those who have access to different modes and are not captive use of any particular mode. The decision on the choice of route. The trip makers on any given trip takes a definite decision on which route to take so as to reach the destination. Again, the decision is available to only those trip makers who have access to mode which can use different routes as a part of research of the trip makers. Such modes would generally include personal automobiles or two-wheelers, etc. Although there is a unanimities on the fact that the above decision can aptly capture the entire trip making behavior of an individual. Hence, he can use to analyze travel demand pattern on an area. It is difficult to ascertain whether there exists a definite sequence in which those decisions are made. Generally, it is assumed primarily for the ease of the analysis rather than anything else that the decisions are made in a strict sequence. Analysis techniques which assume that such a sequence exists are referred to as a sequential demand analysis technique. So, in this figure we can see travel decisions. Any person can take a decision regarding this one, decision to travel. First of all, a person will take a decision whether he has to travel or not. Then after decision of travel, then decision on choice of destination, which destination you want to go. Suppose one has to purchase a cloth and there are many destinations in Lucknow like Aminabad, Hazratganj, Kapurthala, Indiranagar, Patrakarpuram, Gomti Nagar, etc., etc. So, here he has to purchase a cloth. So, he has taken decision to travel. The second step is decision on choice of destination, because there are a number of places from where he can buy clothes. So, he will have to take decision which place he is choosing for purchasing. Then the next, after this, the next is decision of choice of mode, which mode he will go for that particular place, by two-wheeler, four-wheeler, hired vehicles, share vehicles, etc. And after that, then he will decide which route he will go for purchasing their clothes. Although even today transportation demand is analyzed sequentially, the assumption that the four major decisions of a trip maker follow a strict sequence are in the series is possibly not most appealing. Quite often the decision to travel is changed because of appropriate destination does not exist, or any initial choice of destination is changed because it cannot be reached by desirable mode of transport. So, this may be changed. So, travel decision again we have same diagram. This is the structure of sequential demand. In this structure there are feedback loops indicating that the decision taken earlier can be changed based on later decision. For example, the decision to travel may be aborted at the mode choice stage if it is realized that none of the available modes suit the requirements. Then sequential demand analysis. Even though the assumption of existence of a strict sequence is decision making process of a potential trip maker may be debatable. Generally, sequential demand analysis is used to determine the travel demand. As will be seen throughout this section, even with this simplifying assumption of sequential decision making, the analysis of transportation demand remains sufficiently complex. So, here a systematic of sequential demand analysis procedure is given here. These are the inputs, input condition that include socio-economic need, first of all. The second, socio-economic status, and third, network condition. These are the basic input for the sequential demand, and these are the decision to travel, destination choice, mode choice, route choice, and materialization of a trip. So, we can see here the input variables. What are the variables? Socio-economic variables and network variables. So, we can say on the first decision the trip generation model will come in existence. Then the destination choice, the trip distribution model will come. And the third, mode choice or model split will come in existence. And the fourth, after taking the decision of all above 3, then the trip assignment model will come in existence. And finally, the volume on a link or a network. So, this is the sequential demand analysis. On the basis of that, that could be done. The sequential demand analysis, the figures attempt to not only illustrate the logic of analysis procedure, but also give the name of a different classes of model used to. The mathematically describe each decision making phase of the analysis procedure. Each of these class of model is described in detail in the next 4 sections. Before presenting a model, a general overview of the entire process is provided. In this analysis procedure, first the entire study area is divided into various zones. These zones are generally obtained from the land use pattern of the area. Next, for each zone of the total number of trip generated in that zone is estimated using the trip generation model. Given the trip distribution pattern, which is often referred to origin destination OD matrix, these relative share of these trips for different modes are estimated using the mode choice model. Finally, the traffic assignment model estimate the volume of each link of the network by determining the route that will be used by the trip. The basic things are the whole area under a study are divided into different zones depending on the physical or geographical boundary. And in each zone, how many trips are generated and how many trips are attracted in each zone. Then we prepared a origin destination OD matrix. How we will prepared? Suppose certain number of trips are generated in certain zone. So, these trips are origin of trips. Out of these origin generated, then the trips are divided into different zones, zone 1, 2, 3, 4, 5, 6, and summation of these all trips will be equal to the number of zones, number of trips generated in zone 1. Likewise, each zone will create certain trips and that will attract certain trips also. So, in this way we can make a OD matrix like this way. Say this is the attraction 1, 2, 3, these are the zones 1, 2, 3. Number of trip generated in zone 1, suppose that is 100. So, 100 trips could be divided in zone 1 means itself zone, then zone 2, then zone 3. So, this will total will be equal to the total number of trips total. The trips generated in zone 2 will again distributed or attracted in zone 1, 2 and 3. The total summation of trip in zone 1 and 2 and 3 will be equal to total number of trips generated in zone 2 and same way as in zone 3. So, we can see the total number of trip attracted in zone will be summation of this one and this will be equal to this way. So, again in zone 2 the total number of trip attracted will be summation of trip generated from 1, number of trips generated in zone 2, number of trips generated and attracted in zone 2. So, the summation of total number of trips attracted will be equal to the total number of trip generated. So, in this way we can make a OD matrix. So, thank you very much.